Welcome back. Last time we figured out that the roll glitch had something to do with Mario's z-coordinate being changed. You may also notice I've swapped out the graphics plugin in the emulator for something that looks a little bit better. At the end of the last video, I went through a process to try to figure out what was changing the variable. I'm going to go through that again. I think I made some mistakes there. So let's unpause and take a look at what happens to Mario's z-coordinate here in one of our watched variables. So as I roll, it kind of seems to jump up in sudden bursts, and then if I stop rolling, it slowly decreases back to 0. So let's do the same approach. I have the 2, 9, fe4, this is Mario's position vector, and I'm again going to set a right watch on the z-coordinate. So I'm pressing right now. I'll let that go through. We're going to see when we notice a change in the value. Right. Roll is starting. Coordinate's still 0. Aha! That seems anomalous. Okay. So what happened? There's something happened in this function here, the very last line. So let's copy that function. This is 18f bc, which is what I meant to be highlighting at the end of last time. Okay. Nice short function. Okay. So taking a quick look, we can see two arguments are being used, A0 and A1 registers. A stands for argument here. There's some loading of floats into the coprocessor 1 and some storing. Given the presence of the adds, we can take a guess at what this function is doing, but just to be clear, let's look at the first few lines. We're loading offset 0 of A0 into a float register, offset 0 of A1 to register, 4 and F6. We're adding them into F8 and storing F8, the 0 offset of A0. Verify it's happening. Same for the other coordinates, so this is actually just a vector addition function. The purpose of this file is not so much to have runnable code, but just kind of notes on what functions are doing and maybe Python implementations, just to get a sense for details of the functions that may be hard to summarize in words. The z-coordinate change comes from adding another vector to Mario's position vector. The question becomes, what is that vector? So at this point, A1 shouldn't have changed. It should still have its previous value. A0 is, of course, 2e9 fe4, our position vector. A1 is 262 f58. Now that's interesting. That's just before those other variables which I was speculating are Mario's previous position. So let's record that for now. So I'll have that just in case we want it later. Alright, so the addition is happening in this bigger function. So this is a big function. Let's see if we can get a sense for what's going on here. Some stores. You can see looks like A0 is being passed to this function. It's an address. So the addition, this is the vector addition function, it's passing 68 on the stack and 48 plus this S1 variable. Alright, so 68 on the stack. It's T8, just 1c more than 2, 7, which is, alright, so there's a long chain there. That somehow ends up being Mario's position vector. Let's figure out what S1 is, because that's the one we're actually more curious about. That was what was added to the position. So S1, after the load, is offset 84 from A0. So there's some sort of important struct that's kind of the argument being passed here that seems to hold this other information in it. So let's find out what. So A0 is being stored at 70 stack pointer. So let's jump to the stack pointer. 70, 289, F40. So that's right before our position. This might be Mario's, like a struct representing Mario or player character, something along those lines. It's important though, I think. Okay. And in particular, at 84 in that, there's some other vector. Or wait, S1 is at 84. Okay. Offset 84, and then the vector addition happens 48 from that. So S1 is an address. So what was it? I already forgot. Okay, so we have some basic structure going on here. We don't really know what anything is. Let's take a look at this other vector. So this is a relative position, but we can figure out its absolute position just by checking. Well, we already wrote it down actually, right? Yeah. Let's add it to our watched variables. This is going to be the x coordinate. I'm a power user of this software. Probably a lot I can do to increase my efficiency. Now let's just run around. So first approximation, say Kirby. Never mind. All right, Kirby died. This looks like we may actually have found the velocity if I run left, or walk left, so 24, walk right, positive versus negative 24, dashing 44, jumping makes the y positive, one going up, negative one going down. And for most normal motions, it looks like z stays 0, but it's definitely non-zero for the roll. So ever, well, okay, now that we can maybe feel good about this being velocity, let's set a breakpoint, a watch on the, I don't know. I'm just gonna keep calling a breakpoint, a right breakpoint on the z, maybe velocity. Actually, we should probably do a test, make sure this is actually the velocity first. So jump in the air, and let's change our y velocity to be a little bit bigger. Yep, okay. I think this is, we can safely say it's the velocity. All right, great, good to know. Okay, now let's see what's changing this. All right, so it's being, some things happening that are F6 is F2 plus F4. It looks like things are being added to it, but everything's 0 most of the time. So let's try doing our roll. Whoop. Okay, that was a change. So that happened in this function. We suddenly jumped up by 50. All right, let's grab this function. So we're going to kind of ignore this one for now. We have some sense that it has to do with moving Mario. Maybe we should write that down just in case we forget. Okay, new function. Definitely seen a naught. All right. So what do we see here? The a naught that's being passed to it. Something at offset 84. It's possible. So let's check. All right, where are we? This function doesn't affect the stack, and it's stored. Actually, a naught's maybe still a naught. Let's see. Does it call any other functions? Yeah, a naught should still be a naught. So let's see. What is a naught? A0. 29F40. Okay. So this function gets the same argument as this one, this mysterious important struct, which is good news. And v naught becomes that other struct, which maybe is the previous frame. So it's good. Seems to be related to motion. There's a bunch of float calculations here. You can see from the .s that indicates single precision operation. And the important thing is, so our v naught was this thing at offset 84. And at 48, there's a vector. So 50 would be the z component of that vector. So store to 50 of v0, which is that struct. Storing something in the z-coordinate, which is already interesting because, but yeah, so this whole function is only touching the z-coordinate. So out of curiosity, let's see how often this function runs. It's happening right now during the roll. It's like twice per frame. Okay, so this happens twice per frame. I wonder if, actually, yeah, so one thing we can check is if the argument to it is changing. So right now A0 is 32540. Right now it's 29F40. So it seems quite possible this is being called for both characters. It's probably a pointer to a character somehow. Okay, so we're passing in a character. We're loading up this other substruct within it. And then we're doing a bunch of float calculations. This is probably we should be interested in. In particular, though, all right, let's track what's happening to this last coordinate, the z coordinate of what looks like the velocity. So we're storing f12 into it. 12 is coming from 74. 74 f84. Huh. So that's right before this vector in memory, the previous position. We're copying something from there. All right, so we're copying from there. What else do we do? These are just loads, these are just loads. Here we go, storing. So we might store another value in it. But the important part, the part that we were seeing the big jump, was right at the end here. So in that part, we're storing f6. Okay, so we're loading the z velocity into f2, loading this other thing into f4, adding them. So we're adding whatever this is to the z velocity. 60. Let's find out what this variable is. So v naught should still be here, 262f10. And we're talking about 68. Zero right now. So here's a new variable to watch, I guess. And go again. Do that right, 68. Oh no, 7, 8. Okay, so it seems to have the same behavior. In that it's set to something non-zero during the roll. Alright, let's watch this variable then. Okay, this is interesting. The game runs normally, even with the breakpoint set in this variable, except for a bunch of transitions in motion. I go from a walk to a run, I turn around, I jump, at the top of the jump, landing, and then definitely during shield roll. So who's actually changing it? Ooh, that's a big value. Okay. So early on in this roll, we're setting a surprisingly large value here. Probably add that one just for comparison's sake. I guess that would be the x. No, we haven't seen it used. I don't know. All right, I'm guessing this is actually a float vector. We'll find out. It's pretty big. So we're setting the z change to over 100, which isn't big, but given that it should be 0, it's pretty big. So let's find out why. Here's another function. Looks pretty short again. D8C14. Okay. All right, take a quick look. So our modification's happening at C80. Here, we're storing into 68. That's right, that's the one we're looking at. And V0, so this seems to be the same struct. A0, yeah, it looks like we're getting the same character data passed to this function. Let's do another test just to see some of the behavior of this one when this function is called. It's been called during the roll. Okay, so this one stops, wow, during a lot of other motion. So some tax. Ooh, okay. So turning around, this function is called, and during a roll, this function is called. Sliding on the ground. Anyway, we found something important. So its function, it looks like the argument passed to it is, yeah, 29F40 is that maybe character struct. Where again, oh, actually this V0 looks different. No, it's not. Yeah, so 84 from there. We're modifying this z change, specifically, well, I guess there's another way it can happen. Specifically here. Let's keep following the chain backward. All right. Storing F4, and there's some seemingly complicated flow calculation. So let's start mapping this out. We don't know what a lot of these variables are, but that's all right. We'll get there. Okay. So for readability, I'm going to rename A0 to character, maybe. That's a little long. I have tab completion. All right, so V0 is going to be loaded from there, something else is loaded from 74. Something's loaded from v0. Most of this is meaningless right now. Okay, so now we're starting to load actual values and maybe do something with them. Here's the first store instruction. So at v0 plus 60, which is, I guess, the x, if we're right about, where'd it go? 262 f70. So here's the float values we were talking about. Offset 60 is also being set. It seems to be kind of the x sliding. So there's some x component being set here to f16, which is f8 times f10. f10 is somewhat more straightforward. Do we have 74 before? So we're storing f8 times f10, which is... So a lot of this stuff is kind of designed for me to go back in and replace it later when I actually know what it means. For right now, just kind of recording. And then f8 is f4 minus f6. Alright, so we stored that value. Most of the rest of these won't be. Yeah, we overwrite f4. There's some complicated computations going on here that don't make a lot of sense. But sometimes computations indicate intention and what's going on more than a bunch of data moving around, because sometimes there's only so many ways that a certain computation can happen, like movement. You're adding velocity to position. This one's a little less clear, especially because we don't know what any of the important variables are here. Let's skip over this for now. Let's jump back down to the stuff that we care about. So there's a store into that z sliding coordinate. Putting f4 in, it's again a product. We're lucky, we only have to make a few small modifications to this line. Starting to 68 this time, times f18, which is 40, offset 40 in T8 instead of 48. Ooh, that's kind of surprising. Right now, this was loading from 48, this is loading from 40, whereas 60 and 68, like, they're loading from the wrong sides of a vector if that's a vector. So check out the rest. So that was f18. f16 is a product this time. f6 times f10. Okay, f6 is subtracted. So f6, 1c minus, looks like that's same f4 still. And then this is being multiplied by another float value, right, that f10 that we haven't taken care of yet, which is an integer truncation of f8, which is value 57, which is negative a1, which is v0 plus 44. Right. Terrible line of code, but it looks accurate now. Yeah, unfortunately, I can't really begin to guess what this actually means, what this is doing. There's a lot of different variables in the struct that are being referenced. Alright, there's some branching happening. Some functions are called. So within this branch, the z-coordinate can get changed again. In particular, okay, so it can get, both of them can get negated if some conditions are satisfied. So let's start giving some of these things names. We called this character already. v0 that keeps being referenced, the struct at 84. Let's call this character dot previous. I can type. So of course this is going to make it longer. Well, we'll leave it like this for now. Change this formatting a little bit. previous offset 84, but its actual memory address is stored here. The thing we care about in it is 60 and 68. So within previous, there's some, I guess it's an acceleration. And 48 was, 48 was within the character struct. 48 is the, I don't remember what 48 was now. Great. I want to say it was the velocity. Yeah, it's the velocity. Oh, that is within the previous struct, okay. Done some work there. Unfortunately, it looks like any answer to this is going to require analysis of what this function is doing, what these other values are. And that's going to take some work. I think in between this and the next video, I'm going to go through these functions and clean them up. Well, I should probably annotate doing that. Maybe I'll record it, fast forward it, and do voice over it. We'll find out. But I think for now, that's about it. We found a bunch of other relevant variables. We're starting to see some structure unfold here as far as how the data is organized, what's accessing what, what's changing what. We've kind of localized the problem, the source of the problem, to a specific function that is called only when relevant behavior is happening. And it seems to be directly, well, okay, that's not true yet. This modification function is pretty opaque. It's not clear which of these things should be 0. One thing to be interesting, so it was a little, I'm surprised to see how different these two variables are, these two expressions are, and also the fact that if these other expressions being referenced are vectors, they seem to be using, this seems to be using the x modification seems to be using the z component, the z component seems to be using the x component. I guess that could point to some sort of cross product-like thing. It's really hard to say. Maybe the last thing, let's look into, so there's one term that's different between the two. So v0 in this was the kind of that previous struct from Mario. I already have it there, so that's 54. So let's look at what this variable does. Oh, whoops. That's getting confusing. I should get rid of that breakpoint. So as best I can tell, it changes sign when we change direction. There's only ever 1 or -1. I can look at the buttons, I can see what happens if Kirby grabs us. Alright, I don't know if it's mapped to my keyboard, unfortunately. So that's interesting. One of these depends on the facing direction, and it changes the sign of the Z switch. So that suggests, okay. So now if we watch that thing I labeled Z change, the direction changes partway through. That's only if we roll backwards. Alright. No, wait. Hold on a sec. Alright. Yeah, you always end up facing opposite. You face where you rolled away from. So if I roll towards the wall, yeah, I'll always end up facing that way. Okay, so that's not necessarily relevant, but we seem to have found a variable that represents the way the character is facing. Kind of like the projection of their heading along the x-axis rather. So we can name that, I guess. So that is 44 in this struct. Sorry, I also normally annotate the type of these. This is just a word. Okay, I think that's a good place to call it. So yeah, to sum up one more time, we're trying to investigate why there's any change in Mario's z coordinate at all. It's hard to say that this is... it's not like we're going to be able to conclude this is a mistake now, given this line. This seems very explicit. Something is happening when to the z coordinate that somehow gets triggered during a roll. It may be that for some reason there is a small intended z shift, which seems strange when during a normal roll the actual change in the z coordinate doesn't seem to get beyond 100, which is barely noticeable. But nonetheless, something's intentional about it. It's affected by the facing direction, and it relies on something in yet another struct that we're going to have to investigate. Thanks for watching.